Welcome to another do-it-yourself composite tool video from the Ultralight Airplane Workshop. I'm Leon. In this video, we're going to talk about building a temperature-controlled heat box. Now, what prompted this build is that I'm getting close to building the rudder for the UWS-1 ultralight airplane that I'm designing and building. In that rudder, for example, on the leading edge, I have some fairly tight curvature, about a 3-inch diameter radius curve. And I want this 1/8-inch vinyl cell foam to be able to go along that curve. Now, one way to do it is to score the foam, and then it would be able to follow that curve, although I would have some open lines that epoxy would fill and make it a little bit heavier. And I am trying to find ways to make this airplane as light as I can because I want to carry as much battery as I can since we're battery powered. One of the things I want to experiment with is using heat to heat up this vinyl cell foam enough that I can make it pliable, push it into my form, let it cool down, and then it'll hold the shape that I want. So hopefully it won't have crimps, it won't have any extra cuts that will be filled with epoxy, and hopefully be lighter. One of the things I do not know is if using that heat will damage the foam. Of course, if I heat it up too far, it will definitely be damaged. But I'm hoping there's a nice transition temperature there where I can heat it up enough to bend it and have it form a new form, but it won't actually damage the foam. We'll have to find that out. My new shop assistant is here to help out a little bit. But to heat up this foam, I want to build a little temperature controlled heat box. I want to be able to finally control that temperature because I believe that there's a narrow temperature range where this foam will heat up enough to bend but not be damaged. This video is going to be cut up into two parts, well, kind of three parts. But the first two main parts, one is going to be building the temperature controller, basically a thermostat. The second one will be building the heat box. And this is part one, where we're building the temperature controller. I thought about not making a video about this controller box, but then I thought, well, some people who want to do post-cure on the composite parts might find this useful. Let's get to it. About 1.5 years ago, I was thinking about doing this project, making an oven to do post-cure on composite parts. And so I bought this temperature controller. The brand is Inkbird and the model number is ITC-100VH. Now, this is set around in a box for, well, 1.5 years now. And I finally got around to putting this together when I really decided I need to have it ready to go. Now, let me do a quick overview of some of the features of this controller. It runs off AC power out of your wall. It's intended to hook up to a solid state relay to control the heating elements. So it doesn't control them directly, it controls them indirectly. So it's got a 12-volt output to power a solid state relay. And that is what these two outputs are. This is the positive output, here's negative output. It's also intended to have an alarm output. That could be a light or a buzzer or whatever. And that's what these three connectors are for. This is the normally closed, normally open, and this is the common between the two. And whenever you have out of bounds issues on the controller, it gets too hot, doesn't get hot enough, whatever, an alarm will go off. But there's also a little alarm light on the front of the controller. Now, of course, the controller needs to know what the temperature is, so there's a temperature sensor hookup over here. That's pins 3, 4, and 5. Now, on some sensors, you only need pins 3 or 4. Some of them you need 3, 4, and 5. And let's take a quick look at what the front of it looks like. This is the display for the temperature that you want to go to. This is the display for what the current temperature is. This one always displays in degrees centigrade. Some of the older models could actually switch between Fahrenheit and centigrade. This one only does centigrade. Here's those alarm lights I was talking about. There's actually two here on the front. There's a light that comes up when it's running. And then these buttons are down here to set parameters for the device and to run it and stop it. I decided to make my own housing for this controller. And here you can see it laid out. It's 6 inches by 6 inches on the base, and that's this middle square. It's 3 inches high. This is the front panel, all bended up 90 degrees to the base. Here's the back panel. I also decided to put sides in also. So this basically is going to make an open topped box. Then I'll form a lid to screw down over the top of it. Now one of the drawbacks to doing it this way is it makes it a little bit harder to work inside. I probably should have made it a clamshell where I did, let's say, a front, bottom, and back, and then the top had these sides attached to it. But it still worked out okay. Now what I've drawn on here on the bottom is what it looks like with all the components sticking out the sides. Everything's actually mounted to the sides. Nothing's actually mounted to the bottom. This little square here is going to be the hole for the controller itself. And here you can see it kind of sticks pretty far into the box. I'm going to have a lamp to indicate on and off. I'll have a switch to turn it on and off. I will have a fuse here, something I did not draw, but will be right here, will be a switch to turn a fan on and off. This rectangle here is where this little gizmo goes, and this is the solid state relay. So two of the wires will come over and control this to turn it on and off. And then the hot side, the AC power, will come in one side of this, and the output side will then go to the heating elements. On the back end, we'll have an outlet. One side will be for plugging in fan power. The other side will be for plugging in the oven heating element power. This is where power will come in through a cable. And although I did not draw it very well here, this is where a temperature sensor will go. One thing that's needed for this solid state relay is a heat sink. It generates a little bit of heat. And this over here is the heat sink. Now I chose to mount it to the outside of the box. I've seen some people mount it to the inside of the box, which is probably okay if the box is metal. By the way, this is aluminum. It's 45 thousandths thick aluminum. I believe it is in the 7000 series of aluminum. But I've seen some people make it out of plastic. If you're going to put your heatsink inside a plastic box with the solid state relay, you're kind of defeating the purpose of having the heatsink. You're not going to have any air circulation here, and the inside of the box is going to end up heating up. It'll take a little bit longer than if you didn't have the heatsink. But the inside of this box is going to heat up, and you're still going to overheat the solid state relay. So if you're going to put your heatsink inside the box, you need to have vent holes, and you should have a fan to move air through the box. Although you might be able to get away with some convection heating where you have holes on the bottom and the top and the air comes up through the heatsink. Over here is the temperature sensor that came with the controller. Over here is a retaining clip that helps hold this controller from the inside. And then there's a fuse holder, and then there's an on-off switch. We start off by center punching anywhere we're going to drill a hole. These first center punches are at the corners of where we're going to be folding up the box. I'm going to drill a hole there to provide some stress relief so I don't get cracking here at the corners where we're going to have those bends. Now this box really won't ever see any stress, so it wasn't strictly necessary, but I just kind of got used to doing this in the past and I continue doing it. I'm also going to do center punches where I'm going to drill holes for openings, like the outlet, the temperature controller, etc. And while we have a little clip here showing me redrawing the outline for the electrical outlets for the oven and the fan, I'll tell you that I screwed up making the recording just after this, trying to cut out these holes. I used a tool called a nibbler. It can be used to cut little rectangular pieces that's about 1/16 of an inch wide by about 3/16, almost a 1/4 inch long. And what's nice about it is that you can advance it. You squeeze it, it cuts a little piece, drops it, and you can advance it 1/16 of an inch, squeeze it, it'll cut a piece, and you just zoom right along, cutting a long notch out. Now I wanted to show that to you because I enjoy using that tool because it makes cutting out large holes that are kind of an odd shape fast and easy. But like I said, I screwed that up, and unfortunately I can't show it here in this video, but I'm going to have more projects in the future where I'm dealing with sheet metal and cutting out unusual shapes, and I will make sure I get it right next time. I have most of the holes cut out now on the front panel and the back panel. And I have the mounting holes drilled for the solid state relay. So for example, you can see I have these electrical outlets ready to go. Where the cord comes in is ready to go. The fuse, power switch, power light, and the temperature controller. We're all ready to go. I've already done a little bit of bending on this using the pan and box brake. What's nice about this pan and box brake, as you can see, is there's a whole bunch of different segments to it. I've already bent up these sides, and now I want to bend up this and this. Now if this was all one piece, I wouldn't be able to bend this one. This would interfere. It would hit after I got up to about a 45-degree angle. But with pan and box brake, I can remove some of these sections, and I have to have a little bit of a gap in here. But now I can go ahead and bend this. This won't interfere. It'll go around these. So I'm going to go ahead and bend this up. Well, I finally got these bent fairly well. It could have gone better, but we got her done. I've already put one screw in here. I'm going to put some more screws in to hold these four corners in place. I have some self-tapping screws. Now I'm putting these down a little bit because the top plate that goes on here, it's going to have an ear bent down. It's going to come down to about here. I want to make sure these screws are down far enough that that little ear that gets bent over won't interfere. I think the next thing to do is go ahead and make the top for this so I can get all the holes drilled and I won't have as much metal shaving around in the box. Hasn't been screwed down yet, but here's the lid. It's crude but effective. So I'll put a couple screws in here, a couple screws in here, and possibly one centered here and another centered here. And I believe that it will be a box sufficient for what we need. I was going to leave this aluminum box bare, but I had this little can of spray paint. It was flat black I need to get rid of, so I decided to go ahead and just spurt a little bit on here. I didn't bother with primer. I only put one coat on because I only had enough paint for one coat. It probably won't last very long, but it'll look good for just a little while. This solid state relay that is used to turn on and off power to the heating elements is attached to this wall. And like I said before, there's a heat sink that mounts on the back side. Now if there's heat going through there, that means this wall is going to get hot, and that can transfer heat down through the bottom, and through the other walls, and through the other components. So what I'm going to do is drill holes along the bottom here so that if this wall gets warm, heat will rise along this wall and will come out holes along the top. So what I'm doing right now is I'm preparing to drill 2 lines of holes above where this heatsink is going to be. After I do that, I'm going to drill some more holes for this controller. And it's going to set about here. Since it's got some holes in it, I'm guessing it must heat also. So I will drill holes right above where these vent holes are going to be, and holes right below where it's going to be, because it will be here. If this does heat up, we'll get airflow from the bottom through this and through some holes in the top. The other components should not heat up. The switches should not heat up. The outlet could heat up. I hope it doesn't. If it does, I don't think I'm going to do anything to try to cool it off. And of course, the only other thing that might heat up would be this lamp, but I don't think that's going to be an issue. Of course, it would have been better to drill all these holes before I bent up and then painted this enclosure, but I didn't think about it at the time. It's time to start hooking up the electrical part of this gizmo. I should mention that I'm going to create a schematic for the way I've hooked up this box, and I'm going to post that schematic to make it available for my designer and builder tiers on Patreon. I'm going to start with getting the AC wall power into the box. I scavenged quite a few parts from an old toaster oven. In fact, some of those parts are going to be made to create the oven itself. In this case, I'm using the electrical cord and the retainer for that cord. Now I'll mount that into the back of the box. I want to make sure I pull enough of that electrical cord in that the ground can reach where I'm going to hook up the ground, which is fairly close to the input, and that the hot side of the cord can reach the fuse. At this point I kind of spaced out a little bit and forgot that I was supposed to run the hot side of the input cable to the fuse, and instead I started putting on a connector to hook it up to the switch first. Although I did come back and fix this a little bit later. I want to point out one thing here, in that anywhere that I could here in the electrical layout, I used quick connects. And the reason for that is I just didn't feel like doing soldering inside this little box. And so quick connects were a fairly good alternative. If parts fail, they're fairly easy to fix or replace since I don't have to desolder anything. Next, I'll make the little jumper between the switch and the fuse. Fortunately, I don't have to redo this one. One end has a little fork connector on it. That goes to the screw terminal on the switch. I should mention that I'm using 12 gauge wire here, which is overkill. 14 gauge would have been fine. 18 gauge I probably would have been uncomfortable with, but it might have worked. The other end goes to the fuse, which has a quick connect, and it has the male part of the quick connect. And that actually was interfering with the switch a little bit, so I had to bend that out just a little bit. And then this end that goes to the fuse, I use the socket end of a quick connect. I should not need to take the power supply cord in or out anymore, so it's time to fasten that down. The neutral side of the power coming in, I know it's going to go over a screw terminal on an outlet. So I'm going to put a fork connector on there, and then from the neutral side of the power outlet, it'll go to other places in the box. Now I need to make a little jumper from the fuse to the switch. The fuse size uses a socket spade quick connect. The switch side again uses a forked screw terminal. And again, I'm using the 12 gauge wire for this. Well, now that I'm fairly happy with that, I'm going to go ahead and screw in the fuse holder into the front panel. And although you can't see it, I finally got that little jumper connected to the fuse holder. And then, like I said before, the other end connects to the switch. And then, now that I'm happy with that, it's time to hook up the switch to the front panel. Make sure the on-off indicator is in the correct direction. Of course, make sure the switch is in the correct direction. And then screw it on. And I'm going ahead and put the fuse in right now. That's a 15 amp quick blow fuse. We'll have to see if that's really adequate, but I believe it is. Here I made a little mistake. I made a jumper from the common of the solid state relay over to the heater connector on the hot side. That was wrong. I should not have done that. That heater connector on the outlet should have been on the other end of the solid state relay, on the normally open end. And then we need to hook up the ground wire. The ground wire goes from the outlet to the case, and then from the case to the power line ground. The next is to hook up the neutral line on the outlet. Now, I screwed up before, and I actually removed the connector between those two outlets on the neutral side, and that was a mistake, so I ended up having to make a little jumper to deal with that. I took the power on light from an old toaster oven, and I put it in here where the little arrow is, and I'm crimping connectors onto the end of the lines for that power lamp. I need power to the temperature control unit, So I'm making a hot side and a neutral side lines to hook up to that power control unit. And these lines I'm only making 20 gauge because that power control unit really doesn't need much power. Here is where I figured out I made a mistake when I hooked up the heater plug to the solid state relay, where I hooked it up to the wrong side of the relay. So I'm having to undo that and move that connector to the other side of the solid state relay. I have nearly all the power wires done, so now I'm switching over to some of the other lines. In this case, it's the control lines for the solid state relay that runs from the temperature sensor over to the inputs of the solid state relay. And these actually have a polarity, so you have to make sure that minus is hooked to minus and plus is hooked to. And in order to do that, I want it to be fairly easy to disconnect the electrical connections. In this case, we're talking about the temperature sensor connections. For that connection, I chose a 2-pole terminal block. Now, I didn't happen to have any on hand that I liked, so I ended up having to order some from DigiKey. And I had to wait, so I ended up having to put this project on hold for 3 or 4 days while I waited for that to arrive. But with this connector, I can connect and disconnect the temperature sensor fairly easy. You notice here that the wires that I'm going to hook up to the temperature controller to the back of that terminal block are twisted together. That's these red and blue wires. You really want to do that, and the reason for that is electrical noise. By twisting them together, any electrical noise that occurs will occur roughly the same amount on each wire, and then the temperature controller can handle that pretty well. If you have those wires widely separated, you can have different amount of noise on each wire, and that will actually introduce noise on your temperature measurement. So that's a really good idea to do on this particular set of wires. It really isn't necessary for any of the other wires in this box. I still need a switch to control the fan. Unfortunately, this temperature controller doesn't have a way to automatically control the fan, so I'm going to have to install a switch in the front panel. And I happen to have one that's not great, but adequate that I can use from my stock of switches. I'll go ahead and install this and connect it up off camera. With everything now connected and everything else mounted, it's now time to mount the temperature controller itself to the front panel. Well, now that everything's connected, it's time to start checking continuity. Now I have a little multimeter that I'm going to use to do that. First I check to make sure it actually is working. And then the first thing I'm going to check is to make sure that the ground on the plug that plugs into the wall is hooked up to the case. Then I want to make sure the hot side of that plug is hooked up to the hot side of my switch. And I want to make sure it's not connected up to the case. I also want to make sure the hot side is not hooked up to the neutral side. And with the switch off, I want to make sure that things like the heater output don't have any power to it. Now with the switch on, we want to make sure that power actually goes through the switch, but still doesn't go to the heater because the solid state relay isn't on. And with the fan switch turned on and off, we want to make sure that as yet there still isn't any power going to that. And here's where I noticed I had a problem. I wasn't getting power to places I expected it to be. Like one side of the solid state relay, the common side. I also wasn't getting it to the hot side of the fan switch, and I wasn't getting it to the hot side of the controller. So I pulled out the fuse and took a look at it to see if it had a problem. It looked okay. So then I figured it had to be somewhere on a connector near the fuse. And after fiddling with it for a little while, I found out that one of my crimps was bad and the wire actually pulled out of the quick connect. So I redid that, rechecked continuity, and then I had power where I wanted to have power. Before you apply power to a box that you've recently wired, this is something you really should do. You don't want to just apply power blindly and turn on the switch and just hope for the best. You really would like to find obvious problems before you actually apply power. So this is a really good idea to do this continuity test. Well, I finally got to the point where I can button this thing up. Well, let's turn this thing around, take a look at it. It's not too bad for something that was just kind of slapped together without a great deal of planning. And then we will turn on the power and see what happens. Hey, we have blinky lights, we have a power lamp that's on, and after looking at the instruction sheet, I found out that what I'm seeing on the display is telling me that I don't have my temperature sensor hooked up yet, which is correct, so that's great. Let's do a really crude temperature sensor test here. So at the moment it's reading room temperature as being 20.3 degrees Celsius. Now let me just grab a hold of that end of that sensor with my hand, and the heat of my hand should warm that up, and let's see what happens. Well, looks like the heat of my hand is warming up what the temperature is being sensed as. So right now I'm going to consider that to be a success. Now I don't know how accurate it is. I haven't compared it against another temperature sensor, but at the moment I think it's pretty good. I hooked up a lamp to the fan output and looks like the fan switch is working, so that's a plus. I'm pretty happy so far with the build on this temperature controller. One of the things I've done that I did not show on video is I did test the oven output. I can turn that on and off manually. Another thing I'm going to change is this temperature sensor that came with it. This is really more for measuring the temperature of the wall of the oven. Now I happen to have another temperature sensor here with a nice long probe on it, and that'll be better for measuring the air temperature inside the oven. So that'll be a change that's coming up. One of the things I haven't done yet is an automatic test. And the reason for that is I haven't set the parameters for that automatic temperature setting. And the reason for that is I haven't made my oven yet. Now I'm probably over time going to end up making several ovens. This is a standalone temperature controller, and I'll be able to hook it up to any number of different kinds of ovens. But this first oven that I'm going to work on, I'm getting ready to do. That'll be part 2 of this video. And I'm going to make it out of several different things. One of the things that I'm going to use is something similar to this old toaster oven. And I've already torn one apart, and that's this one here. Now this one is a little bit different than the one I just showed you. This one has a fan in it. And that'll be good for circulating the air in it so I don't get hot spots, or at least the hot spots won't be quite as extreme. And I may try to find another toaster oven to add a second fan. Now the fan will run all the time, and I will use this switch to turn that fan on, just leave it on. Although if I run into some situation where I don't want it, of course I can turn the fan off. And I have some old computer cases that I'm going to use because this isn't as big as I want. This will end up being insulated, and so what I'm going to do is make it a little bit deeper front and back, and I'm going to use these larger computer cases to do that. This is really all that's left I'm going to keep of the original toaster oven. I took off all the controls, but I'm going to leave the quartz heaters, and I'm going to leave these spot welded connectors on the ends of the quartz heaters. I'm also going to move the fan to a different spot on the oven. But anyway, that's part 2. That'll be coming up shortly.